Welcome to our third episode in this short series on marine safety and search and rescue. In our last episode, we discussed the dangers of cold water here in BC and across northern Canada. In this episode, we're going to explore some early marine safety solutions. We're going to break this up into two parts. This first episode is going to be for the 1800s and earlier, and our next episode coming up will be for the 1900s and onwards. For this episode of our tour, I decided that rather than follow any strict patterns, we'll go chronologically, based on the earliest records available. I hope you enjoy. Starting off small, we have these here, communication tubes, or as they are more commonly referred to, voice pipes. They were more common on larger vessels where verbal communication became much less efficient due to the size of the vessel. Typically, they would connect key facilities of a vessel where immediate communication of information was vital to their operations, such as the boiler room to the engine room, or the navigation deck to the steering position, and so on. One disadvantage early adopters of voice pipes discovered was they had a tendency to compromise otherwise watertight sections of their vessels. If punctured, they could easily transport water to critical facilities across the vessel. Shutoff valves were a security measure introduced to prevent water traveling from a flooded chamber into other compartments across the vessel via their voice pipes. A crude, but seemingly effective, method of early ranged communication. One of the oldest, most rudimentary examples we have of marine technology here at the Maritime Heritage Center is the brass hydrometer. Hydrometers generally have been in use since the 4th century or 400 CE. The one we have here at the center is an L. Ortling Company brass hydrometer, produced in the 1850s. The brass hydrometer works off of the principle of buoyancy, which, put simply, says that an object will displace a given liquid equal to its weight relative to the density of that liquid. As in, a denser liquid will experience less displacement from a weighted object when compared to a less dense liquid with the exact same object. So, what sailors back in the 1800s would often use this device for was to test the boundaries where ocean and river water met, as it was not uncommon for boats to actually sink when traversing the threshold between fresh and salt water due to the sudden shift in water density. They would collect a sample of fresh water, and using the hydrometer, they could use measurements to determine whether or not it could carry the weight of their vessel as they traveled upstream. The hydrometer is an extraordinarily simple device with quite the important job, but I would say that the simpler a device is, the harder it is for it to malfunction. The last item on our list this episode is a fascinating early melding of chemistry and meteorology. It's a weather forecasting device called a storm glass. This item is a slight exception on this list. Storm glasses generally date back to the early 1800s, whereas the specific artifact we have here at the Maritime Heritage Center dates more so to the 1970s, but you're going to get to hear about it anyways. The storm glass consists of a sealed inner chamber containing a mixture of substances, often distilled water, ethanol, potassium nitrate, ammonium chloride, and camphor. That last element, camphor, is a waxy, colorless, naturally occurring chemical, which is what produces the crystals inside of the storm glass, which could then purportedly predict the weather. The storm glass could purportedly predict the weather based on the formation of contents inside the glass. If the glass was clear, then it meant sunny and clear weather was arriving. If there were small stars like snowflakes, it purportedly reflected thunderstorms approaching. If there were small dots, it meant fog or humidity, and if threads began to develop near the top of the glass, it was supposedly meant that there was strong winds arriving. Essentially, the premise of the storm glass is that temperature and air pressure would affect the solubility of contents inside the storm glass, causing them to dissolve, reform, and congeal based on the weather. The elephant in the room here is, does it actually work? Studies have found that the accuracy of any given storm glass is negligible at best. It's roughly a 50-50 chance that the readings are accurate. It seems much more likely that the glass simply reflects the current temperature present and is thus incapable of actually predicting weather forecasts, but the storm glass can plausibly register changes in temperature and air pressure as they happen, which you could argue you could just as well do with your own human senses. I hope you enjoyed this examination of some early marine safety tools from the 1800s. If you liked this episode, I encourage you to tune into our next one, which will be on marine safety solutions on the 20th century and onwards. Till next time.